Hey everyone! So today we're going to break down a really powerful software design trick, and we're going to do it by looking at something you probably see every single day, your morning cup of coffee. You'd be surprised what it can teach us about writing cleaner, more flexible code. So let's just pretend for a second. Imagine you're building the software for a brand new coffee shop. The very first question you have to tackle is this one. How are you going to represent all the different coffee orders a customer could possibly make? It sounds simple, right? But as you're about to see, it gets complicated fast. Your first instinct would probably take you down one of two paths. You could, say, make one giant coffee class with a bunch of on and off switches, like has milk, has caramel, is decaf, and on and on. Or you could go the other way and try to build a separate class for every single possible combination. You'd have a milk coffee, a milk and caramel coffee, a decaf soy latte with an extra shot. Yeah, you get the idea. The thing is, both of these approaches run into the exact same massive roadblock. And that roadblock is this. The number of possible choices just explodes. It's not just about one or two options. You've got different milks, a dozen syrups, different toppings, sizes, espresso shots. Every single new option you add multiplies the total number of unique coffees you have to manage. Now, this isn't just some phrase we made up. It's a very real concept in computer science. It's called a combinatorial explosion. It's what happens when the number of potential combinations just grows exponentially, making the whole system completely unmanageable. Just look at how fast this gets out of hand. With just 3 add-ons, you have 8 possible coffees. Okay, that's fine. But what happens when we get to 10 options? Suddenly, you're looking at over 1,000 combinations. And if you offer just 15 different toppings, syrups, and shots, well, you're staring down the barrel of almost 33,000 different types of coffee. 32,000. You can't write a class for every single one of those. I mean, it's not just hard, it's literally impossible to maintain. So clearly, we need a much, much better way to do this. And luckily, there is one. This is where the decorator pattern comes in. It's this really elegant, really scalable solution to that whole combinatorial nightmare we just saw. Instead of making a new class for everything, we're going to completely change how we think about adding new features. So what is it exactly? Well, the official definition says the decorator pattern lets you add new behaviors to a single object on the fly, whenever you need to, without changing the original blueprint of that object at all. The keywords there are individual object and dynamically. Now, if that definition felt a little abstract, this quote makes it way clearer. Think of it like stacking Legos. Seriously, you start with a simple base piece, and then you just keep adding new pieces on top of it. Each new piece adds a new feature or a new behavior. It's a really simple idea, but it's incredibly powerful. Okay, so let's put this to the test. We're going back to our coffee shop, but this time we've got our new secret weapon, the decorator pattern. Let's build a custom order from scratch and see how this whole stacking thing actually works. Okay, so watch this. We start with a plain, simple coffee object. That's our base. Now, the customer wants milk? No problem. We just wrap our coffee object inside a milk decorator. Now they want caramel? Cool. We take that new object, the coffee wrapped in milk, and we wrap that in a caramel decorator. An extra shot? You guessed it. We wrap it again. See what happened? We never once changed the original coffee class. We just kept stacking or wrapping new behaviors on top. That right there is the magic of this pattern. The decorator pattern is awesome, for sure. But like any tool in your toolbox, it's not the perfect solution for every single problem. So to really use it well, you've got to understand its upsides, its potential downsides, and you got to know how to tell it apart from other patterns that can look kind of similar at first. The pros are pretty huge. First and foremost, you're not messing with your existing code. You're just adding new decorator classes. That's a massive win for keeping your code stable, right? You can't break code you don't touch. It also means you can add new features, like, say, a new pumpkin spice syrup for the fall, without having to rewrite anything in your core coffee class. You can just build things out, piece by piece. But of course, there are trade-offs. Remember that coffee we built a minute ago? Well, that one order actually created 4 different objects behind the scenes. So this pattern can lead to a lot of small, single-purpose objects floating around. And if you go a little crazy with it, it can make debugging a bit of a headache because you have to trace a request through all those different layers. So the key is really using it where that flexibility pays off. All right, now this is a big one. It's really easy to get the decorator and proxy patterns mixed up. They can look very similar in code, but their intent, their whole reason for existing, is completely different. A decorator's job is to add responsibilities. A proxy's job is to control access to an object. Think of it this way. Decorator adds features, proxy is like a bouncer or a gatekeeper. It's all about the why, not just the how. And you don't want to mix it up with the composite pattern either. They both use composition, but the structure is totally different. Like we saw, a decorator is like a stock of plates, or maybe a set of Russian nesting dolls, one object wrapped inside another. A composite, on the other hand, is all about building a tree-like structure, so you can treat a single leaf and an entire branch the exact same way. So there you have it. We started with a simple cup of coffee, and we ended with this really powerful, flexible way to build complex systems. The decorator pattern is all about dynamically adding responsibilities to objects one layer at a time. So now that you know what to look for, the real question is, where else have you seen this? Because it's everywhere. In file systems, user interfaces, even your online shopping cart. It's all over the place, quietly managing complexity one wrapper at a time.